Hello everyone, welcome to my project. Today we're talking about how to design a stunt performance of flying across certain distance by driving a car. This project is for Applying Physics 1, SI 141. My name's Lei Bao. And let's see a true story. In 1997, for celebrating Britain returned Hong Kong to China, a stuntman named Ke Shouliang wanted to perform a very thrilling stunt performance to celebrate this event, this moment. The idea is how to drive a car and fly across one of the most famous river in China. The name of the river is Yellow River, and then it's 303,095 miles, the second largest river in China. And then, but the challenge of this performance is which spots should they choose to perform the performance? Because the average width of the river is 400 meters. But there's no way you can drive a car and fly over 400 meters. It is impossible, mission impossible. But luckily, they found there is a spot, it's here, named Hukou Waterfall. The distance is only 50 meters. And then because the small distance make it a waterfall. So this is the spot we can manipulate to perform the performance. So finally, they decided to choose a place here. Okay, let's see the challenge. So this is the challenge we have. So we know the distance we need to fly over is 50 meters. We need to calculate very accurate angle. What is the best angle we need to drive a car and fly across this distance? This is the angle we need to calculate. And in our class, we know that there is a certain angle. One object can be thrown the longest distance. We call this is the ideal angle. Firstly, let's see what is the ideal angle can make the car the longest distance. Okay, assume initial velocity is v0. The angle above horizontal line is theta. The horizontal displacement is d. Therefore, v0x is v0 multiply cosine theta, and v0y is v0 multiply sine theta. So this is the something we assume, and then we need to we need the target is what is the theta to make it fly the longest distance. Okay, so this is the formula we need to use here. So x equal x theta plus v x0 plus v0 multiply t. This is for time, and 1/2 multiply acceleration multiply t squared, and we get, so we plug in the number we need. And then we change the sequence, and then we get this. We get here because t time cannot be 0, so the only possible 0 is this part. If this part is 0, so we can get the t. It's v0 multiply sine theta divided by 4.9. So this is the t of the whole process. Okay, so the displacement equal actually is time equals speed multiply speed. So we plug in. So this is the horizontal speed v0 multiply cosine theta and multiply. This is the t we just got. So we get the result here. V0 square multiply sine theta multiply cosine theta divided by 4.9. And we know that there's a formula we can use here. Sine double theta equals 2 multiply sine theta multiply cosine theta. And then we can manipulate this formula to change the previous results into this. So displacement equals V0 square multiply sine double theta divided by 9.8. So according to this result, we can find that because the biggest result of sine, let's say alpha, is equal 1. When alpha, this number, is 90 degrees, and then we can get the biggest number. So that means when theta equals 45 degree, so we can get the greatest distance. We can, for example, like if you drive a car and then the car fly across certain distance, we can, if we set we set angle 45 degrees, which means it can move the greatest distance. Okay, so we know that here is 45. And here is a question. Is that possible? We can set a 45 degrees and make the performance happen. Actually, the answer is no. Why? Here there are three reasons we cannot set the angle 45 degrees. Although it's logically it's okay. We can the 45 degrees can fly the biggest distance, but uh, uh, for the reality, so this is impossible. There are three reasons. First one, the strong wind above the river, which might blow the car away if it stays in the air for too long. We know that the process we just did, and then it gives the car the longest time staying in the air, so it makes it can fly a, a greater distance. But if you stay in the air for too long, the wind might blow away the car, and then we know that um, above above the river, the wind is very strong. So it's very possible to blow the car away. So it's very, very dangerous. So we cannot, this is the first reason we cannot use 45 degrees. The second reason is the bigger angle decelerates the initial horizontal velocity of the car. So this is obvious, but this is not a very, in, this is not very, very important, but still issue we need to consider. Number three is too much vertical speed will cause higher risk when the car is landing. So this might be an issue we need to consider, because when the car is flying above very high, so it gives the car a very high speed to before landing. Before landing, the final speed is very high, so it might cause a very risky result when the car got stopped. And then think about that there is a person inside, so the person might um, suffer a very severe crash before the car is still. So it might cause a very risky result. So according to this, 45 degrees is not ideal, realistic angle we need. So what is the ideal angle? What we need? Actually, we don't need a very long distance. We just need 15 meters. This is what we need. So according to this, we just need the minimum angle, which can make the car stay in the air as short as possible, but can provide just enough horizontal velocity to bring the car to the other side. We just need 50 meters. And then we have to make sure the car staying in the air as short as possible to make the uncontrollable factors less, so to create a higher safety for the person driving the car. In that case, knowing the velocity of the car is very essential because we just need 50 meters. So, and then for a minimum angle, so right now we need to know the, the speed of the car, the velocity of the car to make a exact and accurate calculation. So that's the reason we should choose a car um, as fast as possible. So this is the car which is used during the performance. This is Lancer Evolution 4. And then the acceleration of this car from 0 to 60 miles requires 5.5 seconds. Okay, so let's go over the whole performance. 他的战车再一次从跑道的起点冲向了起跑点，起飞了，过去了，成功了。Okay, so we can see that according to this video, so I make a timing of the running time of the car. It's 7.34 seconds. And then for the picture before, we know that the acceleration of the car is from 0 to 60 miles requires 5.5 seconds. According to these two factors, we can calculate the initial speed of the car. First of all, we need to know the acceleration of the car. And we convert 60 miles per hour to 26.8 meters per second. And according to this formula, V equals V0 plus AT, we have this one. And finally, we get the acceleration is 4.88 meters per second square. Also, according to the same formula, here is the same. And we can calculate after 7.34 seconds, what is the initial speed of the car before flying across the river? It's 35.8 meters per second. So with this, we move on. We move on our calculation. According to the formula, x equals x0 plus v0t plus 1/2 multiply acceleration and t squared. We just plug in everything we know. So 35.8 sine theta is the and then 4.9 multiply t. We know that t cannot be 0. So the only possible 0 is here, this part. So and then we just change their places and we get t equals 7.3 multiply sine theta. This is the time we will have. And then we move on to here. So this is the distance. 50 is the distance. The above is the vertical part. Here we move to the horizontal. Horizontal this is the horizontal speed. Horizontal speed, and then times the time, multiplying the time. So this is the distance we need. So finally we get we get 261.5 0.34 multiply sine, cosine, and sine. Oh, sorry, this is there's something is missing here because when I cut the picture, there's something missing. Um, oh, the equal is missing here. Oh no, it's okay. So we can it's fine because this is the second line. Sorry, this is the second line. So cosine theta times sine theta equals 0.19. Okay, so this is the result we get, and according to the same formula just now, sine double theta equals 2 times sine theta times cosine theta. So we can convert, we can transfer this formula into that. So sine double 2 times theta equals 0.38. And then use our calculator. So we get 2 theta equals 22.3. And theta we got 11.2. So this is the real ideal angle we need, 11.2. This is the angle can exactly help the car make sure the car stay in the air as short as possible the time, and then also you have enough initial speed to fly over 50 meters to the other side. Okay, conclusion. So if in the future, so on Guam, we can have a stunt performance to drive a car and fly the car to a certain distance, we can manipulate the calculation above to help us to achieve our target. So thank you so much for your listening, and this is my project. I hope you enjoy it. Thank you.